Hi, welcome to my first video on sequences and series. And this video is on the introduction to sequences. Definition of a sequence: a set of numbers arranged in a pattern or order. The numbers can be arranged as, let's do the notation like this if you wish. 1, 3, 5, 7, dot, dot, dot. That means they're continuing on with this pattern. Or they could be arranged as in a diagram with a display of 1 dot, then 3 dots, then 5 dots, and then, as you can see, 7 dots. But notice that you're adding 2 here, then there's 2 more and 2 more. So the pattern is displayed here. It's a sequence. They're arranged. These figures, if you want to call them that, are done in a certain order in terms of the dots. Or we could have a statement. 1 cent is placed in a container on the first day. 3 cents is placed in the container on the second day. 5 cents is placed on the third day. And we continue this pattern. So we come up with a sequence. The terms of a sequence are denoted by Tn, where n belongs to the natural numbers and n represents the term, T represents term. So what I have is a sequence here of 2, 5, 8, 11. So this is the 1, 2, 3, 4. This is term 1, term 2, term 3, term 4. And this is what we call 2 is term 1. 5 is term 2, 8 is term 3, and T4 is term 11. So the numbers up above are the values of n, 1, 2, 3, 4. That's the first, the second, the third, and the fourth. But the T1, T2, T3 are the values of the sequence. And we say this is a sequence. And you notice, just to see, you can see that 2 plus 3 is 5, 5 plus 3 is 8, and 8 plus 3 is 11, and you're continually adding 3. Now, we can also fill out a table of values with n and Tn. Again, n is the number of 1, 2, 3, 4. And this is 1, so this is T1, so T1 is a 2. This is 2, so T2 is 5. 3, so this is T3 is 8, and T4 is 11. So n is the number, and Tn is the value of that term. Or we can do a graph, another way to represent it. N, this is the values of n, and this is the values of Tn. That's like an x and a y. But notice the table of values, I'm going sideways, and there's a reason for that as we move on in the sequence series. So when n is 1, right here, Tn is 2. When n is 2, Tn is 5. When n is 3, Tn is 8. And let's say 3, 8, right there. And when n is 4, right here, we get 11. And that brings us up to roughly about there. And if you notice that these are dots. So, because they're dots, notice also that n belong to the natural numbers. So this is 1, 2, 3, 4, 5, 6, 7. These are the natural numbers. The terms, the number of the first, second, third, fourth are the natural numbers. And we also notice that n is not 0. Because when you start to do a sequence, you got the first term, second term, third term. You don't have a 0 term. So n is not 0. And also notice that Tn is not equal to 0. There's no 0. Tn cannot have a value. That means that's because n is 0. That means we have, when I say Tn can't be 0, Tn is not equal to, I should say, a number. So there's no Tn intercept. Because we don't have n as 0, we will not cross this axis. If you think of it, that's the y-axis. And also, notice that the graph is dots. The graph is a set of dots, and a set of dots is discrete. Discussed that earlier on in the linear. This is discrete data. Notice discrete data, dots. You cannot join these because you only have the first term, second term, third term. There's no 1.5 terms. And also, if you want to, this sequence is a function. It is a function because it passes the vertical line test. And the vertical line test, if I draw a vertical line through this point, it only passes through one point. Passes through this point only, passes to this point only, or passes to this point. So draw a vertical line, it will only pass through one point. Or we can also say for each value of n, there is only one value of Tn. There's two ways we can say it's a function. Okay, let's move on. Also, another way we can display the information is with some sort of a diagram with some pattern in starting with the first one. So if we say this is the figure, this is figure 1, this is figure 2, this is figure 3, this is figure 4. And if we say these are the dots, then the number of dots here is 3. And it's 3 plus 2 is, 3 dots now. Wow, why did I say, I said 3 and wrote down 4. That's, got to be careful what I'm, part of my disability, but if I make a mistake, then I try to correct it. This is 3 dots. This is 2 more, so that's 5. That's 2 more, so that's 3, 5, that's a 7 dots. And that's 3, 2 more is 9 dots. So again, we got the figure, term, figure 1, figure 2, figure 3, figure 4, and we got dots as 3, 5, 7, and 9. So if we call this, we can call this N, or we can call this F. We can say N or F, but if you use N and T of N, you could also use F and the F of N, either or. Figure the number of dots. Anyway, this is 1, 2, 3, 4. And if we want, I forgot to fill in the 5th term of the pattern. So we have 3, and then 2, and then 2 more, and then 2 more. So the pattern is I have to put 2 more on. So that makes a total of 11. Notice we're adding 2 on to each term. So these first term, add 2. That's a 3, add on 2 is 5, add on 2 is 7, add on 2 is 9, add on 2 is 11. So a 5 will give me 11. A 1 gives me a 3, 5, 7, 9, and so again, N, even though it's a figure in dots, N represents the figure, and Tn represents the number of dots that's in each of the figures. And we graph this. Again, this is N, and this is Tn. And when N is 1, Tn is 3. When N is 2, Tn is 5. When N is 3, Tn is 7. When N is 4, Tn is 9. And when n is 5, Tn is 11. Again, what do we have? Again, notice that n, keep emphasizing this, in a sequence, n belongs to the natural numbers 1, 2, 3, 4, 5, etc., etc. And notice that n is not 0. And notice that the graph is dots. And there's no Tn intercept. There's no Tn intercept because n is not 0. We don't have n 0, so we can't put any dot on this. And also, the graph is a function. And just to remind too, we could look at it this way. We could look at the domain. The domain is a set of x, but in this case the domain is a set of n, and the domain is n belongs to the natural numbers. That's your domain. Domains are the values of n in a sequence, and they're always natural numbers. Let's look at another one. Statement. Stones are placed in a box. Day 1, we have 1 stone. Day 2, we have 2 stones placed in. Day 3, we place 3 stones in. Day 4, we place 4 stones in. So, if day 1, we put 1 stone in. Now, day 2, we put 2 stones in, so that makes it 3 stones. So, if this is your day, which is 1, 2, 3, 4, etc., and we have S as stones, this is the number of stones. So, on day 3, we put 3 stones in. So we put 2 in here, we put 3 in here, so that's a 6. Now on day 4, we put 4 in, so that makes it 10. So on day 4, there's 10 stones in. So notice now, just go up here. Up here, we're adding 2 on to each one. But down here, we're not adding 2 on. Here, we've added 2 on, then we've added 3 on, then we've added 4 on. So sort of a little, it's a sequence. There's a different type of sequence, and we'll get into that later. So we have day. We could say day. N is the number of the day, and Tn is the number of stones. So we got 1, 2, 3, 4, 1, 3, 6, 10. And so this is N, and this is Tn, and we have that's a 4. That's 1, 2, 3, 4, just put some, that's a 5, 6, 7, 8, 9, that's 10, 11, 12, 13, 14, 15. And so when n is 1, Tn is 1. When n is 2, Tn is 3. When n is 2, Tn is 3. When n is 3, Tn is 6. When n is 3, Tn is 6. When n is 4, Tn is 10. When n is 4, Tn is 10. Now, what I want to show you, notice here we're adding on 2 each time. Notice if I put the ruler on this set of dots, what do we have? We have these dots are forming a line. But notice in this one, because we're not adding the same number on, we have a different type of sequence. Notice when I put the line on the first one and the second one, it doesn't go through these two. So this is not what we call forming a line. And we'll discuss this in further videos, not right now. And again, it's Tn, n belongs to the natural numbers because it's 1, 2, 3, 4, etc. And notice that n is not equal to 0. And the graph is dots. In other words, we can't shade it in. And there's no Tn intercept. Or we could look at it in terms of x and y. There's no y-intercept because n is not 0. And the domain is, you could say the domain D is n belongs to the natural numbers, and your domain is the natural numbers, and the graph or the data represents a function. Why? Because it passes the vertical line test, only passes through one point when I draw a vertical line. Or for each x, there's only one y. X doesn't repeat. Let's continue. Let's look at some sequences and fill out some examples of sequences, but this time we're looking at some equations. And sequences can be different. Notice that in a sequence, n belongs to the natural number. That's the domain. So this is n, and this is tn, like an x and a y. So when n is 1, so the t of 1, n is 1, the t of 1 is 4, 1 plus 3. 4 times 1 is 4 plus 3 is 7. So when n is 1, tn is 7. Now we're going to do a 2, a 3, and a 4. So the t2, 4, 2 plus 3, 8 plus 3, 11. So 2 is going to give me 11. And t3, so notice we're putting 3 here and 3 here. So t3 is term 3 is 12 plus 3 is 15. And we're going to do n is 4, so the t of term 4, t4, 4. N is t4, put a 4 in, plus 3. 16 plus 3 is 18. 16 plus 3 is 18. 19. Sorry about that. But what do you notice? These are going up by 1, and these are going up by 4s. So if you add 4 on, 11, add 4 on, 15, add 4 on to get 19. So when I made a mistake just then and put 18, I noticed that there was 4 here, but I should have 4 here. Okay, and we have another one. Tn is n squared plus 2. So we have n belongs to the natural numbers. So we have an n and tn. We got a 1, 2, 3, 4. Now there are more terms here, but I'm only doing a few of them. So t1 equals 1 squared plus 1. 1 squared is 1 plus 1 is 2. t2. t2 is 2 squared. So it's 2 squared plus 1. 4 plus 1 is 5. So 1 is 2. 2 is 5. So t3 is 3 squared plus 1. 9 plus 1 is 10. And t4 is 4 squared plus 1. 16 plus 1, 17. Notice this time, this one is going up by 4s each time, but this one goes 3, and then a 5, and then a 7. So this one's a little bit different in relation to, but it's a sequence. It's a pattern in these numbers. Another type of sequence is Tn equals 3 times 2 to the n minus 1. And again, remind, n belongs to the natural numbers in a sequence. So this is n, Tn. So therefore, the t of 1, 2, 3, 4. So n is 1, 2, 3, 4. So the t of 1 is 3 times 2, 1 minus 1. Notice n is 1. Put a 1 here and a 1 here and work it out. So 3 times, we got to work the exponent out first, which is a 0. 3 to the 0, or sorry, 2 to the 0 is 1. Any number to the 0 power is 1 except 0. 0 to the 0 is undefined. So that's a 3. So T2 is 3 times 2. So n is 2, n is 2. So put 2 here and 2 here and work it out. 2 minus 1 is 1. 2 to the 1 is 2 because we got to work our exponent first. Powers. So that gives me a 6. So 1 is 3, 2 is 6. And T3 is 3 times 2, 3 minus 1 again. N is 3, N is 3. 3 here, take your time. We do the exponent first, which is a 2. Now in PEMDAS, we have to do the power first, which is a 4. And 3 times 4 is 12. And we do N is 4. So we put 4 in the place of N. Work the exponent out, which is a 3. That gives us 2 cubed. It's 2 times 2 times 2. It's not 2 times 3 is 6. It's 2 times 2 times 2, 8. So that gives us a 24. And if you notice that we're starting with 3 and we got a 2 over it, so that's a doubling. Notice 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, so we're doubling each term as we go. And we have another type of sequence coming up. We'll do more explanation as we go. We're just introducing the sequence now. What this unit is all about. Notice we have T1 is a negative 3. Notice we have Tn is negative 2. This is n. This is t, n minus 1 plus 6. And you might say, well, what's going on? Well, first of all, we have to obey that n's got to be greater than 1, and n belongs to the integers. Now, why we say n is greater than 1? Because t1 is already here. So I can't put a 1 right here. Because n is already 1 here. I can't put a 1 in this expression. Because if I put a 1 in, t1 is going to be a negative 3. So I have to put n greater than 1. That means I have to do n is 2. So that means I'm looking at n is 2, n is 3, and n is 4, and n is 5. But I only want to find T4. So I can't find T4. I'm just going to put that here just for a second. Watch. T4 equals negative 2, T4 minus 1 plus 6. So T4, there's 4, n is 4, n minus 1. So that's negative 2, 3 plus 6. So in order to get T4, I need to have what T3 is. So what we have to do is start with n is 2 and work that out. And when we get, that's n is 2, so that means T2 is negative 2 and 2 minus 1 plus 6. So notice n is 2. Fill in the 2 in this equation. We do. So we get, that's 2 minus 1 is 1. So notice now we got T1. We know what T1 is. T1 is a negative 3. So because we know what T1 is, then we get 6 plus 6 is 12. Now we got T2. Because we have T2, now we can go and get n is 3. So that's T3 is negative 2. N is 3 minus 1 plus 6, negative 2. 3 minus 1 is 2 plus 6. So that's negative. T2, we found it out here, so we put a 12 in now, which is negative 24 plus 6. Negative T is 12, so that's negative 18. And now we can get the T4. So it's negative 2 T of 4 minus 1 plus 6. Negative 2, and that's T minus 1 is 3. So now we have negative 2. T3 is negative 18 plus 6, and that's 36 plus 6, which is 42. So notice I cannot get T4 right away. So we have to build up. We have to start with T1, find T2, then take T2 to get T3, take T3 T3 to get T4. And we'll learn the names of these as you see the next video. So again, something different, but this is how sequences can go depending on which sequences you're going to do, the type of sequences. Also, a sequence can be named with the function notation. F of n is equal to negative 2n, where n belongs to the integers. So n can be a 1, 2, 3. So let's work out the f of n is 1. So the f of 1 is negative 2 times 1, which is negative 2. And now let's work out the f of 2. F of 2 is negative 2 times n is 2. That gives you negative 4. And the f of 3. Again, the f of 3, n is 3. So you put 3 here and 3 here. And that's negative 6. That's in a function notation, very similar to Tn notation. And again, notice n belongs to the natural numbers. That's the domain of these sequences, natural numbers, 1, 2, 3, it's over. And now we have another one to do, a little bit different, but you just got to be careful. We want to find the f of 3. Notice we have the f of 1. So again, notice n is greater than 1. We can't put a 1 in. 1 is already done. So 1 gives you a 4. We can't put a 1 in here because we got to put in where n is greater than 1. So that means we can put in n is 2 and 3 and 4, etc. But we want the f of 3. If I put the f of 3 in, if I put 3 here and 3 here, that's the f of 3 minus 1 is a 2. So I don't have the f of 2. So I got to go and work out the f of 2 first. So that's when n is 2. So take the equation, f of 2 equals the f of 1 plus 3 f of 2 minus 1. So notice I'm doing the n is 2. So n is 2, I put n is 2, and I take my time and work it out. So this is the f of 1, 3. I work out inside the brackets first, that's a 1. So work out the bracket and I get a 1. Now the f of 1, look up here, is a 4. And the f of 1 is a 4. And we multiply first, PEMDAS. We can't add to get 7, then multiply. We have to multiply these two first to get to 12. And that gives us a 16. So now that I have the f of 2, I can find the f of 3. So the f of 3, I'm putting 3 in the place of n. So the f of 1, copy it down, plus 3, f of n is 3. 3 minus 1. And take our time, the f of 1, 3. This is 3 minus 1 is 2. I have to simplify the bracket. And now, this is the f of 1. The f of 1 is 4. And this is 3. F of 2. The f of 2 we worked out to be 16. And again, PEMDAS, we have to multiply first. We can't add these first. We have to multiply, and then 4. 3 times 16 is 48, and that gives us 52. So this is a little bit, it just takes a while to get to this, but you will see this as being a system in the next equation, or a sequence called recursive. But we'll talk about that when we get to the next video. We'll be doing some of these. And that brings us to the end of our first video. And if you like my video, click on the like button, subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.